Consider the circuit shown in the figure and the value of all the capacitance is given. So what is the total energy of the system, energy of each capacitor, and whether they are equal or not? That's what statement C is asking. So remember that they are in parallel. So the capacitance across the voltage across the combination is 90 volt. When these two individually are in what do you call it as in the series, so definitely their charges is going to be same. So let's say this is Q and this is Q. Let's call it Q1 and Q1. And let's say this is Q2 and this is Q2 because their charges are after all same in the series circuit. Okay, let's try to find out the, um, we know that the potential difference across this is going to be same, is going to be 90 volt. So can we say that their total charge, what their effective capacitance will be? That will be C1 C2 over C1 plus C2 because they are in series. So that is 4 times 7 over 4 plus 7 is 11. So that will be 28 over 11. So what will be the charge? Charge is going to be CV. C is 28 over 11 and V is 90. And remember the capacitance is in microfarad, so we'll just carry the micro sign of the thirds. So that is going to be 90 times 28, which is 2520 over 11 microcoulomb. This is the charge. Okay. So if this is the charge, then, and in fact, this is the charge Q1, right? And now we can easily find the energy which is being stored in it, right? Energy which is being stored. By the way, this is the C effective of the upper one. What is the C effective of the lower one? The C effective is going to be C3, C4 over C3 plus C4. That's going to be 6 times 3 over 9. This is going to be 2 microfarad. 2 microfarad. And these two in turn are in what? Parallel, right? So that if net capacitance is going to be the addition of both 28 over 11 plus 2, so the energy is going to be CV square over 2. We know the C, which is 28 over 11 plus 2. So that's 4.55 times 90 square over 2. And this energy is definitely uh, what do you call it as? Okay, they are interested to find the energy in millijoules. This energy is in microjoules because capacitance was in micro, but definitely we can convert this up. 4.5 into 90 square over 2 divided by 1000. So this value is coming as 18.43 millijoules. That is the answer actually to part A. And for part B, I'm working over on the right. We found Q1. Likewise, we can get Q2 as well, which is the C effective over on the downside. This is for the upside. For the downside, which is 2 times potential is again 90. So that will be 180 microcoulomb. So their individual energies for C1, for example, is going to be Q square over 2C. So that's Q1 square over 2C. Q1 square over 2C. So Q1 is this and C1 is 4. So I'm just going to substitute this value. 28 times 90 over 11, by the way, is uh, 229.09, and that's what I'm going to substitute over here as well. So this number square over 2 times 8. And definitely this is Q square and this Q was in microcoulomb. So make sure we do the appropriate conversions as well. So this value is coming as when this is divided by 1000. This, since we are interested in millijoules, so this value is actually coming as Q square over 2C, where Q is CV. So Q is in microcoulomb and C is also in what do you call it as microfarad. So this value is coming as 6.56. That is for C1. Likewise, I'm just going to keep substituting as the numbers. So C2 is going to be Q1 square over 2 times C2. And what is the value of C2? That is 7. So all I have to do um, is get this value calculated for 7. So this value will be coming as 3.75 for C2. Likewise, for C3, that's going to be Q2 square over 2 times C3. What is Q2? I'm sorry, Q2 is 180, right? Here, 180. So it's 180 over 2 times 6. 180 square over 2 times 6. So that is coming as 2.7 millijoules. Everything is in millijoules. And C4 will be coming as again Q2 square over 2 times C4. And C4 is what? 3, right? So that's going to be multiplied with 6 divided by 3. So that's coming as 5.4. Now the question is whether all these are equal or not. So it's only a matter of calculations. Let me just add 6.56, 3.75, 2.70, 5.40. So yes, indeed, because there is a decimal approximation over here. So definitely all the energies are eventually going to come same over here. So we'll say that the sum of the energies stored in the individual capacitors must be same as the energy stored in the system. Thank you.